You are welcome to JoeNewton Online Physics and Maths. Okay, this is physics class. So we are now to learn physics. And precisely, our concept has to do with momentum and the impulse. Of course, we are going to meet acceleration also in this question because we are still treating the mechanics, which some students find difficult, especially calculation aspect of it. Then, the question says, a ball of mass 400 grams moves at 30 meters per second. When you hear meter per second, what should come to your mind is velocity or speed. When acted upon by a force of 2 Newton for 1.5 seconds, we are asked to calculate its momentum, impulse by the force, acceleration of the body. Okay, solution. So this is a combined question. We write out the parameters given to us. We are given the mass of the body, M, to be 400 grams. But we are not going to work with 400 grams in this mechanism because it's not a standard unit. Since it is not a standard unit, we ought to convert that 400 grams to kilogram by dividing it with 1000. So we have 400 over 1000. Of course, 0 cancel. 4 over 10, our M now is what? 0.4. So the kilograms. That's our mass we are going to work with. So first of all, inspect to make sure that it is in standard unit. Then we are given the velocity V is 30 meters per second. We are given that the force F is 2 Newton and the time is 1.5 seconds. So the time is in standard unit. Had it been that the time is in minutes, you multiply by 60 because 60 seconds make 1 minute. Okay. Now quickly, for the momentum, we call it particle momentum. P is equal to mv. That is mass times velocity of the body. So our particle momentum, our mass is 0.4 times the velocity 30, and that will give us 0.4 times 30. We are going to get 3 times 4 is 12. You see it? How to work this? 3 times 4 is 12. And the 30 times 4 will give us 120. If 30 times 4 will give us 120, but we'll have one decimal place here. So we write that 120 and put one decimal point. So 120, put one decimal point here. So we are left with 12. So we have 12 kilogram meter per second square. How do we get this unit? The unit of mass is kilogram. Velocity is meter per second. Sorry, meter per second, not per second square. The unit of mass is kilogram. Velocity is meter per second. So the unit now becomes 12.0 meter per second. Because 30 times 4 is 120. We have one decimal point and we'll put it. Okay? We go to II. II asks us for impulse. The impulse, which we represent with I, is equal to average force that acted times time, F times T. So our impulse is equal to the average force given is 2 Newton force. The average time for which it acts, the total time it acts is 1.5 seconds. So 2 times 1.5 gives us what? 3. So we have 3. Force is in Newton, time is in seconds, 3 Newton seconds. So this is how to get the units. Simple, conventionally. Force is in Newton, time is in seconds, and this is multiplication. So it's just 3 Newton seconds, not per. And even that is ratio over. When you have per is when you have over, that is per. Then I, acceleration of the body at that time, remember we have that F is equals to ME. That is force equals to mass times acceleration. For uniformly accelerated body, a body accelerating in a straight line like that. So looking for A will now be equal to F over M, which is equal to our F is 2 Newton, our M is 0.4. How do you solve this? Don't worry, you don't need calculator, just look at me. It becomes 2 divided by 0.4, which is divided by 4 over 10. Remember that 0.4 is something as 4 over 10. So this will give you 2 over 1 times 10 over 4. That's what it means when you put sign of multiplication. So this is how to treat this in example with your calculator. So 2 here, 1, 2 here, 2, 2 here, 1, 2 here, 5. So our acceleration is equal to 5 meter per second square. Remember, the unit of acceleration